This is Geometry, Unit 10. We are modeling objects. There are numerous objects in the world that people often need to measure in order to solve a problem. However, not all objects are perfect geometric objects. Therefore, people model real-world objects with geometric objects that most closely resemble. So an apple, what geometric shape have we talked about in the past that an apple resembles?
A sphere.
So we would call that a sphere. So a sphere is pretty much a ball. And an apple is in the shape, theoretically, of a ball. A dumbbell. A dumbbell, you could say, could have two spheres on either end. You could get crafty and call them hexagon. So you got a hexagonal prism. You have two hexagonal prisms with the cylinder in between. So whatever detail, whatever measurements that you know that you have, probably be a little bit easier to call them spheres. So we would have two spheres and we would have a cylinder. How about a tent? What geometric shape represents a tent? Very nice. Notice here that we have our triangle. And then we come on back. So we have a triangle all the way through the shape. The sides are rectangles. So this is a triangular prism. Very good. Okay, how about the grain silos?
Cylinder.
We have a cylinder. So you could get detailed and talk about if the top looks like a rounded hemisphere. So that would be half a sphere. You could say half a sphere and a cylinder. Okay. And then this last one, you don't really see a side view of the house, but think of the house kind of like that. What shape or shapes, it's two different ways at least we can do this. What do you see when you look at this?
A triangular prism on a rectangular prism.
Beautiful. A triangular prism and a rectangular prism. So we would have two different calculations for that. Some people may call it a five-sided. The base has five sides, so a pentagon. So some would call this a pentagonal prism. So that's two different ways to have considered this. You could say a triangular prism and a rectangular prism. You could get away with pentagonal prism. So sometimes there's more than one way. That should give us the two different calculations should be the same. So now if we flip over here to our person, our crash test dummy, we're going to calculate the volume of this human. Or not so much a human, but of a human using this crash test dummy. So if the head is considered a sphere, and we know the volume of a sphere is 4/3 pi r cubed, if in the crash test dummy the diameter is 17, then we know the radius is going to be half of that at 8.5. So our volume is going to be 4/3 pi 8.5 cubed. So we have 4 divided by 3 times pi times 8.5 to the third power. And that gives us 2,572. .44. These are centimeters cubed, so cubic centimeters. Then we look at the volume of the neck. What shape would that be? Cylinder. If you ever have a question on what to call it, look at the dimensions that they're giving you. Here they give us a diameter, so you know we've got to calculate in some sort of circular object. And they give you a height. So that would be the height of the neck, apparently. And those would be dimensions needed for a cylinder. Those would not be measurements we need for a sphere. Perhaps we could use a cone out of that, but we probably agree that our necks aren't so conish. Okay? So the volume is pi r squared times the height. If the diameter is 8, then the radius is 4. So the volume is going to be pi r, well our r actually is 4 squared times the height. And that's 8.7. So pi times 4 squared, which is 16, times our height, 8.7, we get 437. 31 centimeters cubed. How about the torso? What shape do we want to call the torso?
It's kind of like a trapezoid, so kind of a rectangle.
Okay, we could get away with a trapezoid perhaps, but looking at the dimensions that they give us, they don't give us two base lengths. They don't give us the length across the shoulders being different than the length across the hips, which perhaps it would be, but in this case, they just give us a width, a height, and a depth. So we'll call that a rectangular prism. And the volume of a rectangular prism, besides the base times the height, would be length times width times height. So 41.5, 59.6, and 17.7. And that gives us 43,779. And those are still cubic centimeters. How about our arm? With the dimensions that they're giving us, we would consider this a cylinder. We know that that's pi r squared times the height. We have a diameter, so we know we're going to have 4.05 for our radius. So pi times 4.05 squared times our height, how long it is. So we have pi times 4.05 squared times 57.5. And that would be the volume of our arm, perhaps. Now, how many arms do we have? We have 2 arms. So if we times this by 2, we're going to get 590 or 5,925.95. Those are cubic centimeters. How about your fists? What shape would these be? Right? If you make it into a fist type shape, clench up your fingers into a ball, that might look like a sphere. You could probably also do it so it looked more like a rectangular prism. But with the shapes that they've given us, the dimensions that they've given us, the sphere seems more appropriate. So our radius is going to be 3.75. We know the volume is 4/3 pi r cubed. So we type that into our calculator and we get 220.89, and we know that we have 2 fists, so we times this by 2 and we get 441.79. Now, what would you like to call the pelvis?
It's also trapezoid, but it's more like triangular, so triangular prism.
We could probably call this a triangular prism. We have a width, we have a height, and we have a depth. So thinking about our triangular prism, we have a width of 38.3, we have a height of 14.5, and then it's going back our 17.7. So the volume is going to be, for the triangular part, it's half what's considered the base, and we use a small b when we talk about a triangle base, times the height. That's the triangle shape. Then we would typically call it a height for the whole figure. So we kind of have a height 1 and a height 2. So our height 1 would be 14.5. That's the height of the triangle. And then when we talk about a prism, the height is the distance between the triangles. So this would kind of be our depth number. That is our height number 2. So the volume is half 38.3 times 14.5 times 17.7. There's our half. 38.3, 14.5, 17.7. We get 4,914.85 centimeters cubed. Now, how about a leg? Looking at the dimensions they give us, what shape would we have? A cylinder. And we know that that is pi r squared times the height. So if our diameter is 12.3, then our radius is going to be 6.15. So the volume is going to be pi times 6.15 squared times the height, the length of the leg. They sometimes say if you eat a lot, you must be filling your hollow leg. So here we are. What is the volume of a hollow leg? So pi times 6.15 squared times 76.1. That gives us 9,042.42. Those are centimeters cubed, cubic centimeters. A foot. Yeah, looking at the dimensions they give us. A rectangular prism, typically known as length times width times height. 9 times 26.3 times 9.6. 2,272.32. Now, how many feet do we have? We have 2 feet. So we can times that by 2. And we get 4,544.64. And those are centimeters cubed. And back up here at the legs, we would have two legs. So to find the total volume of the legs, 18,084.84. That would be both legs put together. So what we're going to do now is find out the total volume of a person. So we take our 2,572.44, 437, 43,779, with two arms. We'll do the double number. We've already done the calculation of times 2. The two fists, the one pelvis, the two legs, 18,084.84, and then the 2 feet, 4,544 and some change. So our total person, oh, that's crazy. Our total volume, we have 76,614. It looks like exactly centimeters cubed. So now we're going to take our person, we're going to jump in a car. How many people can we get to fit in a car? So the approximate volume of a smart car. If you get on a website, you can typically find what the volume is of your vehicle. They're saying that this one is 57.4 cubic feet. And that would pretty much have to take up every nick and cranny available inside the car. Using your approximate volume for a human, how many people could fit inside the car? Oh, that's crazy. Now, they have their units as feet cubed. We have our units as centimeters cubed. So we know a cubic foot would be something like that, where it was 1 foot by 1 foot by 1 foot. That's a cubic foot. But if it takes 30.48 centimeters to be one of the dimensions, or you could say to be each of the dimensions, it's going to be 30.48 cubed to figure out how many cubic centimeters are in 1 cubic foot. So 1 foot cubed is going to be equal to 28,316 and a little bit extra centimeters cubed. And then if there's 57.4 of those, so we times this by 57.4, that's going to give us 1,625,386. And almost another. So that's how many cubic centimeters are fitting inside a smart car. Now if we take that whole 1625,386 and divide that by our person, how many people are going to fit inside the car? $16,253.86 divided by 76614. Oh, this one looks like 21 people. We've got 21.22 people mathematically can fit inside the car. Do you think we can get that many in? Probably not. We're going to watch a video and we're going to see if we can get several people into a smart car.